So 5.4, sum and difference identities. We have the identities in this box that are new to us. And again, you have to memorize all of these. All right, you will not be given them. Okay. So this is for if you have sine of two different things, right? Not sine of 60, but if you have sine of, let's say, 45 plus 30, right? Or cosine, or if you have a difference, if you have, let's say, sine of 60 minus 45, right? So if I have sine of 45, I know what to do with sine of 45. If I have sine of 30, I know what to do with sine of 30. If I have sine of 45 plus 30, together, that's sine of 75. I don't know what to do with sine of 75 if 75 is written as 75. However, broken down into the sum of two angles that I know how to deal with, that I can deal with these sum and difference identities. And so now, look here. It's sine of A plus B, and then you've got this mess or a string of things here, right? So let's take a look at this. Sine of A, cosine of B, plus cosine of A, sine of B. So let's try to make sense of this, right? Because you do have to memorize, but it's always like good to understand and not memorize, right? So look, you have A and B in this order, and here you have A, B, okay? Plus. So do you see a pattern there, right? Now, if you have sine of A minus B, again, you have AB, same order. Minus, okay? Let's look at the cosine. You have cosine A, cosine B, sine A, sine B. Okay, this is different. However, it's still AB, right? The same order. Okay, so now let's think of a more concise way of writing this. So if this is a plus, you get a plus here. If this was a minus, you get a minus here. And this could be a more concise way of writing these two formulas in one. All right? And here, the difference here is, look, for the cosine, if this is a plus, this is a minus. It's different. So if this is a minus, this would be a plus, as it's stated here. So if I look at these two, right? You know that song? What is that? Like that nursery rhyme song? No, not that one. Okay, so look, this is like, if you write them like this, sine and then cosine, it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. And I know it really doesn't do anything. All it does is add a rhythm to it. But you know what? Somehow it makes sense, right? So if written in this order, it's sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? And so that's kind of what I use to do this. So before we go to the, okay, so now that's that. We're going to practice a little bit with it. Look at the tangent. You have to memorize it, but there's also a way to make sense of that, right? The way I look at the tangent is tangent of A plus B. First, you give each one its own tangent. So tangent of A plus tangent of B. And then 1 minus tangent of A, tangent of B. It's not that bad to memorize. We're keeping AB in the same order. So let's do one and see how we can put it into practice. So look at this one. This is the same example as we had before. 75 is not a special angle. So I don't know what sine of 75 is on the unit circle. However, I can write 75 as a sum of two special angles. And now, this is sine of A plus B. And because it's the sine, it's the first part of the song, right? So it's sine, cosine, cosine, sine, right? So, and then I'm going to keep A and B in the same order. So it's going to be sine, cosine, plus cosine, sine. Right? So really, I'm focused on the pattern, sine, cosine, cosine, sine. And then the 45 and 30, I just like transcribe in the same order. Now, look, I can do this because I know what sine of 45 is. It's 1 over root 2. Cosine of 30 is 1/2. plus cosine of 45 is 1 over root 2. Sine of 30, if the cosine was a half, then the sine has to be, root 3 and 1. Okay, there we have it. And so now this is root 3, if I combine these, over 2 root 2, plus 1 over 2 root 2. So this will be 1 denominator of 2 root 2, root 3, plus 1. And that's your answer. This is how we leave it. You don't have to rationalize your denominators. Yes. Wait.
Does it matter if the sine is greater than 45?
No, doesn't matter because addition is commutative, so it doesn't matter. But keep the order the same.
Look if you put root 2 over 2
Okay, no. Okay, so you are not required to rationalize the denominators. However, okay, this is what I was going to say next. Suppose you did, in this step, worked with rationalize root 2 over 2, root 3 over 2, root 2 over 2, 1/2. It's the same, but now you've rationalized all your denominators. Here, you will get a denominator of 4, root 6 plus root 2. These two are identical. And me, at this stage in my life, because I've done 3 million of these, when I see either of these, to me, they look the same. So on your test, I see no difference between the purple and the blue. You can write whichever one, as long as it's right, whichever format is fine. In the book, the answers are rationalized. So if you get this one, but the book says this, it's just the rationalized version. Okay, now let's do a different one. Okay, so look at this one. Here I have sine of negative something, correct? So look, here we're going to use an identity. Sine of negative theta, I know, is negative sine theta. So I can rewrite this as negative sine of 7 pi over 12. And if this was cosine of negative 7 pi over 12, how would it be rewritten? Just cosine of 7 pi over 12, because the negative angle doesn't do anything to the cosine. Okay, now, here, this is negative sine of. Now I want to split this into two angles, right? Okay, so here's what we do. This is how I do it. I'm very methodical, right? Because sometimes they get a little crazy. And if you're taking your test and you're frazzled, we need a good way of doing this. I have a denominator of 12 here, so let's do this. And let's go ahead and put in the pi's as well. So now, I need two numbers that satisfy two conditions. One is the two numbers have to add to 7. Second, when I put them here, they need to reduce to special angles. So again, because I'm a methodically minded person, I do this very systematically. I start with 1 and a number, 1 and 6. If I put, don't write this, but if I put 1 and 6, does the 1 over 12, that doesn't work. So then the next one would be 2 and 4. And does the 2 and the 4 work? Oh, 2 and 5, sorry. That doesn't work, does it? How about 3 and 4? Okay, 3 and 4 works. So that's what I'm going to get. So now let me rewrite this. This is negative sine of pi over 4 plus pi over 3. So now this is negative, in parentheses, sine, cosine, minus or plus? Plus cosine sine, because there's a negative out front and it belongs to everything. Cosine sine. Right? So do you see this? So it's sine, cosine, cosine, sine, right? And then the plus here means a plus here. Okay, now don't forget about the negative out front. This is negative, so you could do brackets or parentheses, I don't mind. So this is negative of, what's sine of pi over 4? 1 over root 2. Cosine of pi over 3, 1/2, plus 1 over root 2, root 3 over 2, negative, what is this? 1 plus root 3 over 2 root 2. Okay? So let's talk about how to write this. I mean, this is pretty much like, the solution, right? Now, different ways to write that same thing are, you can distribute the negative, so you get negative 1 minus root 3 over 2 root 2. You can put the negative out here, 1 plus root 3 over 2 root 2, right? Or you can give the negative to the denominator, 1 plus root 3 over negative 2 root 2. Now, I know you're thinking, okay, which one do I put on the test? Honestly, the right one. So whether it's this one, this one, this one, or this one, they're all the same. So you have 4 choices how you want to put it. However, know that all 4 of these mean the same thing. So if you're taking a multiple choice test at some point, you don't know what format the answer is going to be given to you. And you don't want to be frazzled because placing the negative is not a Precalc Honors standard. That's more like, I don't know, Algebra 1 standard, right? So know how to do this. Okay, yes.
If we wanted it, we can just leave it in.
Correct. Okay, so now, these are identities, right? And we said in the very beginning of this chapter that a trigonometric identity is basically 2 equivalent trigonometric expressions that are placed next to each other with an equal sign. Which means if I tell you x equals 3, I can also tell you 3 equals x, right? So that also means if my trig identities can go this way, they can also go this way, right? So a big part of this is also recognizing a pattern, right? So if I was walking down the street and I saw a billboard, and on the billboard it said sine 30 cosine 45 plus cosine 30 sine 45, in my mind I'm like, oh, that's sine of 30 plus 45, right? Because that's how my mind sees it. Similarly, if I see this tangent of something minus tangent of something else minus over 1 plus tangent, right? I'm like, wait a minute, let me look closely at this. Tangent of A minus tangent of B, 1 plus tangent of A, tangent of B. Wait, that's the sum and difference identity for tangent. So now, is this tangent A plus B or A minus B? It's minus because I know that transfers from here, right? Okay, so then that whole mess is just tangent. That whole thing, numerator and denominator together. 78 minus 18. But wait, how much is that? Oh my gosh, but wait, how much is that? Root 3. Okay? The answer then, root 3. Okay? Do you see? One-step problem pretty much, right? Okay? Here we go. Look at this one. What do we think here?
That's probably a cosine.
No, that is a cosine.
Cosine, cosine, sine, right? So this is like the second part. Cosine, cosine, sine, sine. Okay, so this is definitely a cosine. I have an A. I have a B. Now, is this a sum or a difference of a cosine? Difference, right? Because with the cosine, the plus changes to a minus. So this is cosine 7 pi over 8 minus 5 pi over 24. Okay, and then we're going to do like common denominator, right? So this is cosine 16 pi, no, yeah, over 24, which is how much? By 8. Cosine of 2/3 pi, negative half. You see that? There is no other way to do it otherwise, because we don't know what 7 pi over 8 is if you don't have a calculator. okay? Because it's not one, like we don't know cosine of 7 pi, right? Because it's not a special angle. However, using a special angle identity, using a sum and difference identity, I can do this without a calculator, okay? Okay. Okay. So, yeah, 16 pi. Because you get 21 minus 5. Yeah. What about the signs? Okay. All of it together. Cosine, cosine, sine, sine. All of it together is cosine A minus B. When you expand, right, it's all the same. And then when you condense, it's cosine of A minus B. Okay. So here we go. So now that was like basic cosine of A plus B. But A and B can be anything, right? It could be a number, it could be an expression, like this one. Look at what we have here. Let's zoom out. I have cosine of, so first of all, when I first see this, it's overwhelming, right? But if it was assigned to me, that means it's something that I am supposed to be able to do in this context, right? So now let's look at it more carefully. Let's read this. This is cosine of something plus something. So this is cosine of A plus B. But you know what else? This arcsine of root 3 over 2 can actually be simplified. How much is that? Pi over 3. So now if I rewrite this, this is just cosine of pi over 3 plus arc cosine of x.
I thought when you have arc cosine and the cosine would cancel out.
But you don't have arc cosine and cosine. You have cosine of something plus arc cosine. You have cosine of A plus B, right? That's a different thing. So now this is a sum and difference identity for cosine. Okay, let me do this one. So look at this. We're going to expand A and B. So this is cosine. So it's going to be the second part, right? Cosine, cosine, sine, sine, right? Okay, cosine, cosine minus sine, sine. So do you see? Again, when I'm saying it out loud, I'm focusing on the pattern. Cosine, cosine, sine, sine. And then mentally, I just transcribe A, B, A, B. Okay, now, let's see. What's cosine of pi over 3? 1/2. Times. Okay, now, Shayna, what's this? That's x. You see that? Now that's a different thing. Yep, that's x minus what's sine of pi over 3? Root 3 over 2. Because if the cosine was 1/2, then the sine has to be the other one. Okay. This is a whole other thing. In chapter 4, just that blue thing was its own 4-point problem. And now that, because we've come so far, that used to be its own problem is now just 1/4 of another problem, right? So how did we do this back in chapter 4? Well, you draw a triangle with, this is theta. The cosine of that is x over 1. So how much is this missing side? 1 minus x squared. And now I want what of this? The sine of it. The sine of that angle is 1 minus x squared over 1, but obviously you don't need to put the 1, okay?
But just as a reminder, the missing side is always 1 minus x squared.
If it's a leg, right? It's the square of the hypotenuse minus the square of the other leg, or if it's the hypotenuse that's missing, then you add the 2 legs. Okay, so now x over 2 minus root 3 times this over 2. But we don't leave it like this. you want to multiply the two roots. So this will be also in one fraction, x minus inside the root 3 times 1 minus x squared over 2. And before you ask me, do you need to distribute the 3? That's up to you. This is okay. Or 3 minus 3x squared. Either of these are okay. Right? So do you see how just this blue part, right? This was like one of the questions on your chapter 4 test. Just this. And now just that is part of a bigger deal, right? And so on the chapter 4 test, when the expectation is for you to be able to solve this problem within a minute, it's because when you're solving now 15 of these new types of problems, you really don't have more than a minute or even half a minute to do this, right? So that's right, that's what we're doing. And that's why this was stressed in chapter 4. That's why I was on the test. That's why, like, like it's all part of like the big game, right? Okay. Okay, let's do another one. Look at this. Sine A minus B. Okay. How much is this though? You can simplify this. Okay, one of them. Which one is it? Let's get a consensus. Oh, we're still not agreeing. Which one is it? I need a consensus.
It's over 3.
Okay, pi over 3. Pi over 3. Sine of pi over 6 is a half, but cosine is sine of pi over 3 is root 3 over 2, but cosine is a half. Okay, so let me rewrite this. This is sine of, okay, and look, arc tan x, it's like more writing, like you can rewrite that. That's up to you as inverse tangent of x, right? If you wanted to, that's fine. There's nothing wrong with that. Okay. So now this is sine, right? Sine, cosine, cosine, sine, right? So sine, cosine, minus cosine, sine, right? Right. How are we doing? Okay. What are we going to do for the first one? Triangle. Okay. So tangent is x. Is that right? Is that how I do it? So then here, what will this be? The square root of what? Is that right? X squared plus 1, or does it have to be minus? It's plus, exactly. Well, you gotta be sure, okay? It's x squared plus 1, okay? So now here, I want the sine of this, so that's x over x squared plus 1 in the square root, times, okay, cosine of pi over 3, 1/2, minus, what's the other one? Okay, here, right. But it's a sine. Okay, so this one, we're back at the triangle. Now we have 1 over the square root of x squared plus 1. Sine of pi over 3, root 3 over 2. Okay. Both have the same denominator of 2 square root x squared plus 1. But the numerator is how much? X minus root 3. And that's it. Huh? If you do it what? Oh, I'm sure I can come up with one that's not. So, yeah, don't just, yeah. Yeah. Because if it was like a tangent, it might not be.
What
You know
we
what I
found
mean?
a cosine.
Yeah, probably. You know what? Just don't generalize. Just
Okay.
do one at a time. Okay? There's like sometimes we fall into. Okay. Okay, questions. Okay. So now, the next thing we're going to do is verifying some stuff. This one here, cosine of negative theta equals cosine of theta, that's an identity, right? That's an even and odd identity, right? So now this question is saying verify. In math, when we use the word verify, we're not asking you if something is true. We're saying what I've told you is true, period. Show that it is. Okay? That's what the word verify means in math. So to do these things, now this was like a big thing. The section 2 of this chapter is all verifying identities. And more and more, like as the years go on, they're not really like stressed in high schools anymore. That's why we didn't do section 2. However, the concept of it, just like doing 2-column proofs in geometry, the concept of it is important. Okay? So when you verify identities, you keep one side untouched. This isn't like a law in like set in stone, but it's a good practice to keep, right? So in this case, we're going to keep this side untouched. I'm going to work with this side. So how can I verify that cosine of negative theta is in fact cosine of theta? We illustrated it with this, right? Cosine theta, that is not a proof. That is an illustration. To do a mathematical proof, here's what we're going to do, to verify. Okay, so this is cosine of. You think to yourself, okay, what's a way to write, okay, the gum. Okay, all right, what's a way to write negative theta? Okay, well, one way to write negative theta is 0 minus theta. Okay, and now how would you know to do that? You wouldn't. Now I've told you, and now you know forever. Okay, that's kind of how like learning math works, right? Okay, so now all of a sudden this is a difference of cosines. So it's cosine, cosine, sine, sine. So here we go. Let's do this. Okay, cosine plus sine, sine. And now cosine of theta is 1. Cosine of 0 is 1 times cosine theta. Sine of theta is 0 times sine of theta. 0 times anything goes away. What I have left is 1 times cosine of theta. That equals cosine of theta. So there we go. I verified it. Because cosine of 0 is 1. Right? So verifying identities is you keep one side the same, you work the other side until one side equals the second side. Okay, let's do this one. So cosine of theta minus pi over 2 is this. This is also an identity. It's the cofunction identity. The way we have it, just so you know, if you're comparing, the way you have it in the list of identities, it's always pi over 2 minus. But why in this case can we say both of these are the same? Yeah.
Because the minus signs are moved by the cosine.
Perfect, right? Because if it's a cosine, you can have the negative of an angle and they're the same. Excellent, good. Okay, so we're going to keep sine of theta the same and work on the more like complex side. So this is going to be cosine plus sine, sine. Okay, cosine pi over 2, 0. So that whole thing is 0. So I just get plus, right? Sine of theta. What's sine of pi over 2? 1. So that sine of theta equal to sine of theta, yes. They're all going to work because that's what verify means. Okay? You're never going to get one that doesn't work. It's not going to be a trick thing. Like, that's not what we're doing. Okay? We're doing them like the process. Okay? All right, questions? Yep.
So if instead it was cosine and it was sine, would then instead of just putting pi over 2, would you have to write negative pi over 2?
Well, no, if this was sine of theta, pi over 2 minus theta, then it would have been equal to negative sine of theta, and you work it out and you get negative sine theta equals to negative sine theta. Like, so this identity, right, it comes to you as it is, like out of the box, right? So like you will just be given, oh man, that was a long time ago, wasn't it? You will just be given like one of these, right? As they come, okay? And then, so if you're given this one, you work on this left side, and then you get 0 minus sine of theta times 1, negative sine theta equals negative. It all works out in the math. Trust the math because it's bigger than us. I always say this.
I have a question. How come the original is like theta minus pi over 2 and then like in the form we're writing pi over 2 minus theta?
That's what Ryan was saying, right? Why is it Ryan? Say it again. Right, so the difference between this and this is one is the negative of the other. But we know that for cosine, if you have negative of an angle, it's the same as cosine of the positive of the angle. So if you have the negative of 1 with cosine, the cosine keeps like it just engulfs the negative, so there is no need to change. Okay, let's do an equation. Okay, so we're going to solve this over the interval 0 to 2 pi. Okay, so similar to section 3. Okay, all right, look at what I have here. It's a lot. Here I have sum and difference, sum of cosine, right? Cosine, cosine, sine, sine. So let's just first take care of that. Cosine, cosine, minus sine, sine. Okay, and then I have a minus, right? This minus here. Yeah. And then I have this one, which is another difference of sine to sine. This is sine, cosine, cosine, sine. So because of this negative, I need a parenthesis here. Sine, cosine, minus cosine, sine. Is that right? Equals 0. Okay, let's simplify what we can simplify. What's cosine of pi? Negative 1. What's sine of pi? 0. What's cosine of pi? Negative 1. Sine of pi, 0. Okay, so let's just rewrite all this, right? So here, I get negative cosine of x. This whole thing is 0, right? Because it's sine times 0. Minus negative sine of x, right? Minus 0. Okay, because sine of pi is 0. So it looks more complicated than it is. So this is negative cosine x plus sine x is equal to 0. Yes? Okay. Now I need to solve this. Now we have to use our skills from like section 3, right? Which you're going to be quizzed on next Friday. This one, however, I particularly put this one because this is kind of a different one, okay? Definitely more than one way to do this. One way to do this is this. If I take cosine to the other side, right? Let's just do that just for fun. What do I get? Sine of x equals cosine of x. So now, when I solve an equation, I'm looking for all of the values of x that satisfy this. So for what values is sine equal to cosine? And
Yeah, 3 pi over 4.
here?
Or 5 pi over 4.
5 pi over 4, right? Because over here, sine and cosine are both root 2 over 2. Over here, sine and cosine are both negative root 2 over 2. So those are the ones. So I say x equals pi over 4, x equals 5 pi over 4. Okay? Yep.
You also like split them all, set them to 0, and then just
No.
no.
No. The other way to do it would be you can maybe square both sides, right? It is more complicated. So you get cosine squared x minus 2 sine x cosine x. Yeah, plus sine squared x equals 0. And then look, cosine squared plus sine squared equals what? 1, right? And then it's a bit more complicated. But honestly, don't do that, right? Oh.
Can you just divide by cosine and
No.
tangent of x equals 1?
You can do that as well.
Yeah.
You can do that as well. Okay? But also, just by looking at it, we're like, yeah, pi over 4 and 5 pi over 4. That's when the two of them are equal. Yes.
We only check for strings root over square.
Correct. Yep, so these are good. Okay? All right. And if this was not from 0 to 2 pi, if this was like over all of the real numbers, what would it be? Pi over 4 plus pi n. Okay? All right. No, because they're 180 degrees apart. Okay? All right. Okay. Let me finish this next one, and then if I have time, we'll take a question. Okay. Now, so this is something that comes up over and over and over again. This is part of a definition from calculus, right? That requires you to build a function. And then sometimes, like when we're teaching calculus, building that function sometimes takes more time than the calculus part of it. And so I'm like, okay, it's a good idea to start now. So let's do this. We are given that f of x equals cosine x. We want to expand the formula for the difference quotient. That's what this is called. This. Okay? So I want to create g of x equals blah, blah, blah. Okay. So think of g of x as like a recipe, right? And what does that recipe call for? It calls for f of x, right? Which I know what that is. F of x is cosine of x. So now what would f of 0 be? Cosine of 0. What would f of a be? Cosine of a. So what would f of x plus h be? Cosine of x plus h. But now that in itself is a sum of a cosine, right? Cosine a plus b. So this is cosine minus sine. And there is nothing else you can do to simplify this because you don't have any values. They're both variables at this point. So now, to build this quotient, g of x is f of x plus h minus f of x over h. So g of x is, well, f of x plus h is this. Okay? Minus what? Cosine of x all over h. Okay? And that's how we leave it. That's it. Because this is like the non-calculus part, and then after this, it's like the calculus part will take over, but right now we need to build this. So we're going to see this again in different chapters. We're going to see it in chapter 12, then you're gonna see it like it's gonna be like a part of life in calculus. Okay? Okay, yes, Josie, did you have a question first? Oh, yes.
For the f of h, f of x plus h, why is the like it turns into the cosine of x, but why is the h in the parentheses? Why wouldn't it just be like cosine